Whenever you're ready, sir.
Hello, hi, Professor and TAs. My name is Yusuf Abdi, and my project mate, Cesar Hernandez. Both of us, we going to go over on clinic assertation model. Um, so to talk briefly about the clinic assertation, the background the model permits healthcare professional to analyze unstructured clinical notes, also representation of clinic relevant information. So the model is so important information extraction system used in the healthcare. So our objectives is we will apply the uh, uh, natural language processing and healthcare informatic, my apology, revolve around the accurate extraction and classification of clinic information from unstructured text resource. Also, we will apply several models to have a better understanding the model. Next.
So in our data collection, there were some bumps in terms of like the medical data was extremely difficult to find due to privacy regulations. But some of the features in the models to include unigram, unigram, bigram, bigram and trigram, and then just trigram alone. And the models we used to apply our data set regarding clinical assertions are as follows: the ngram feature representations, k-nearest neighbors, random forest classifier, the decision tree classifier, XGB classifier, the TSNE of all features vectors, the neural network, and the CBOW and skipgram models. And next, I will go over the ngram model we added to the dataset. So with the basic ngram model, we can assist in automatically categorizing clinical text into assertion categories. So as you can see here, we have, absent, possible, and present. So overall, the model performed good in classifying the instance labels of present and absent with high precision, as we can see with the bar graph. But the model did struggle with accurately identifying instances labeled as possible. Then the next model, the k nearest neighbors, and the visual graph I used here was a heat map. And so based on this confusion matrix, represents how well the k nearest neighbors models performed regarding the present, absent, and possible classifiers. So from this heat map, we can see that classifications are being confused. From the results, we can see the precision of present is high at 0.84, which indicates the model will predict an instance of present as correct most of the time. Furthermore, the recall, for example, the part for recall under present class is also high at 0.92, which indicates relatively few false negatives. Again, which is good. And then our next model, the random forest classifier, and again here showing a heat map. For this, again, it showed relatively good numbers. For example, present, the precision came out to 0.83, indicating that the model predicts an instance as present. So it got it correct approximately 83% of the time. Now, this information can guide us to further improvements based on this model or the previous one that I just discussed, such as exploring other classifications such as algorithms to enhance performance, especially for the possible class, as you saw in the bar graph. And next, I'll pass it over to my partner, Yusuf.
Okay, so the other algorithm we applied is a decision tree classifier. The task is to construct a tree to predict discrete labels. So the data point starts from the root and continues to split features that result in the most significant information gained. So, and each internal node corresponds to the feature and branch represents. So the tree stops growing all instant in the node has same class and reach the maximum length. So the classifier text classification, we applied the metrics as you can see on the table. We have a different factorization, unigram considering precision, and also recall comparing to precision, and bias toward the predict the majority class. Slides drops the metric and adding the toward the big, bigrams, and also toward the bigrams, the precision increase the number of you can see in the table, and recalls decrease, which indicates the model performed strongly. And on the trigram, vectors fell lower score, and the metric F1 micro indicates room for improvement. The precision is higher than recall across all the vectorization techniques and predicts all correct. Next slide. And in this chart, the training model sample is 3,998, and the testing set we took it's 1,000. The data set colored according to true class level 0, 1s, or 2. And the region shares to indicate areas of features space that classifier has learned from associated with each class. And the region represents the feature space area that the model will predict certain class, and the decision tree makes these boundaries. Next. Here, the XGB classifier enable in the model techniques, and here we are looking the systematic solution to combine the predict power of multiple learners, and also we imported the usage of decision tree. The goal is to regulate to prevent overfitting. In the table, vectorization techniques, the unigram, the model applies individual words as featured. The bigram operates the bare consecutive word as features, and the unigram, bigram, the model using both individual words and bare consecutive words. Trigram, the model is using triple consecutive words as featured, and the bigram trigram, the model is using bare and triple consecutive words feature. The metric of F1 microscore calculates the label and the average, also average it. The precision macro is calculated for each level as averaged, and the recall is calculated each label, as you can see in the label in this table, then looked across all the average. The last column, test predict score, the score indicates the model permitted better. Next slide. Similarly, this graph contains performance of metric classifier with the different visualization and returns the best performing factorization and classifier. So looking to TSN visualization, all features, factors, you can go back to the previous slide. Yep. Look into how the data points are clustered in the low dimension space. The TSNE is performed with the two component plotted in 2D scattered plots. So each we have specified for visualization each features, the unigram, bigram, and bigram trigram. So look into this TSN chart. The first two features, unigram and bigram, the highest density area is points are closed and backed in the middle, and the data sample is similar, indicates the similar features value. This means they have a common frequent. If you look the second, the bigram and trigram, the density in the middle, it's it starts scattering and far from each other. Also, the other algorithm we applied is a neural network. And so if you look the input layers, the shape output, that is included with the batch size, we applied the dense area of neural network that has 2048 neural network activation. The dropout also we did it with the 0.5 regulation. We applied the kernel weight, all density activation function, which is the hiding density layer, except the first one, and the output layer is the 3 neural network, and all will be shown in the code. And if you look to the F11, this visualization, the features performs terms all the features. The corresponding F1 score is from 0.82 and 0.85, 0.75, all the way to 0.86. The accuracy is 0.8 and 0.83 and 0.76 and 0.78. That's what we got it. Next slide. CPO, CPOW, and also we applied the skip gram. So the both algorithm use produce embedding that vectors representation. Both are common in word vector modeling. This embeds captured the semantic meaning of the similarity and representation. More specifically, CPOW model predicts the current word based in the context, which skipgram use the current word predict and surround the context. In our case, which you can see in the TS model, we use the library of word two-factor implementation. So then we initiate the TSNE, two component of the 2D visualization, then fits the TSNE model word vector to obtain from the COP and skipgram models. And also we explore the quality learning of embedding, and also we try to understand the semantic space and get a potential improvement in the word embedding process. Each point represent in the word reduced to space. The cluster of the point indicates are used similar context, large density between the cluster suggests the less similarity between the two groups of word representation. The outliers of the cluster represent the word unique, meaning that are distinct from the rest of the vocabulary. Now I'm going to hand it over to Caesar.
Thank you. So in conclusion, our project, we tested on different learning models, such as the random forest classifier and the decision tree classifier were explored for classifying clinical assertions. So utilizing different models, it allowed us to compare the performances to be able to identify the most effective approach to our specific data set. The use of such metrics such as accuracy, precision, recall, and F1 score helped us evaluate and select the best performing model. Although our models did show promise in classifying clinical assertions from unstructured text sources, there is room for improvement to better capture nuances and complexities of clinical narratives. Then references, and I'm gonna stop sharing.
Thank you.